Cool. All right. We are back for another Friday. It's hot. I'm in Miami Beach. The AC went out. So we're going to try and make this one a little quick. Today's topic, I saw a couple of things going around as far as messages and questions that basically boil down to design. So um, I ran into another set of instances where this was a machine learning specific item, and another architect was asking for reference architecture material specifically in the machine learning space for a particular industry, as a medical industry scenario. And the customer was looking for something that boiled down to a classification problem, and they were also looking for something that was a recommendation problem. And one of the things that struck me with this was that they're just first thing they're going to go do is just find a reference architecture for a particular industrial need. And I'm just not really sure that that's the correct way to go about doing this. One, actually in the last session we had talked about how one of the customers used a reference architecture and got themselves into trouble. Reference architectures tend to solve a problem for about 80 to 90% of those with that particular problem. And then the other 10 to 20%, it doesn't solve it for them. And also they tend to be pretty flexible and non-specific to a particular scenario. So if you're working with an actual customer, like I don't think the solution here is to just grab one of these examples and use that. Maybe that's a starting point, but I kind of wanted to talk a little bit about just solution design holistically, and what I end up doing to make sure that we land on a good design. So typically we'll schedule a meeting, and I like the customer to come prepared with a bunch of stuff. And when I tell you what I want my customers to come prepared with, you're going to see that there's a direction that we're heading in, which ends up getting us on really good content. So I'm going to actually read out I literally send this email content. I'm not going to share the exact email because well, I can probably copy paste this, but I haven't checked it out for too much other stuff. I'm going to read it and remove and not say things I shouldn't say. So anyways, these are things that I look for, that I want customers to come prepared with if we want to build something that ends up being good. So we'll start here and then see what people's thoughts are, because this isn't exactly agile. So first thing is, what in the world is your concrete business problem? And what do you want me to do with you? Like, let's just start from the beginning. What is your business problem, and what are we helping you to do with that? So in the scenario where the person was asking for assistance for the reference architecture, they appeared to know, generally what the business problem was, sort of. They want to do classification. Okay, cool. Where, what, how, kind of stuff, right? Like, are we doing this on a server? Do we need to do this on a device? I don't know, right? Like, what are the, like, what's the connectivity look like? What's the rest of the stuff look like? So we'll see. We go into further. So the next thing I ask for them is, I want to know what your current design looks like. I want to know what system we're talking about. I want to see that pictured. I want to see what touches the system we're talking to. And I want to be able to understand why you built it like you built it. Maybe you had good reasons. Maybe you didn't. I don't know. We should look at that. The next, inside of that drawing, I also want to be able to see if it's a cloud, because almost always it's cloud or hybrid. I want to see in the cloud section, make sure we include things like management groups, subscriptions, resource groups, identity platforms. If it's a hybrid situation, I want to be able to see what data centers, what connectivity, what comms, like routers, like all the the infrastructure stuff. Like, show me what infrastructure this is running on, and I'd like to know what capabilities that infrastructure has. A lot of times those are multiple drawings. Third thing I want them to bring is the proposal. It's like, you're gonna talk to me and not even have taken a stab at this yourself. Like that's not. I mean, we should help with that, but like, dude, take a stab at it, and then let's talk through what you picked and why you picked, not just like start. Because if a customer comes in and then they want me to do all the drawing and they haven't taken a stab at it, like, then it's less advisory over something that they are trying to design and more of me building for them, which goes kind of against the concept of helping people learn how to fish. Like, I want you to be successful with you, and not you have to come back to me all the time, because there's a lot of folks that we need to be able to help and serve. And my goal really is to get you self-sufficient with your things so that, like, I don't have to talk to you again. Not that I don't want to talk to them, but like, it'd be great if they were just capable of doing it themselves and maintaining and owning it themselves. That'd be a wonderful spot. All right, cool. So I want them to take a stab at what they should be doing, and same set of drawings, same exact drawings as the previous one. Just what's your proposal? The next one is the workload layouts in the infrastructure, and that's kind of an if statement. 9 times out of 10, like, if there's virtual machines involved, this is true. I want to know, like, what workloads are you running on what machine? So if you're running like a SQL Server and an MQTT and a ASP.NET web application and like 5 cron jobs on the same virtual machine with 1 CPU, and you're saying you're having performance issues, well, that's the drawing that's going to tell that to me. The other ones where it says I've got 2 virtual machines or 5 virtual machines, like, that doesn't really tell me that. It's this drawing that tells me where we can have a lot of potential issues in those areas. The next thing that I look for, we're at 1, 2, 3, 4. The fifth thing. Sixth thing. We're on the sixth thing. The sixth thing I look for is the desired build, delivery, and continuous improvement processes for the machine learning system, or any system. I put ML system in this one because I'm making them think that I do this specifically for ML. I do the same questions for every system that we design. In the other talk about machine learning ops demystified, like, you'll get to it, like, it's just the same darn thing instead of DevOps, or they call it ML ops. And like, people get hung up on these words, so I try to remove the fancy jargon, and I try to lay it down in common words. Desired build, delivery, and continuous improvement processes for whatever you're building. Yeah, I'm going to build it, I'm going to deliver it once, and then I need to continually improve it and deliver it. Yeah, and then I want to know how this subsystem, because I was brought in to help with just a particular subsystem, so I need to know how the other subsystems talk to this particular piece of the system. And I asked them to just talk from a process perspective. Like I said, don't bring me all your drawings for this one. Let's go through the process. The technology usually matters a lot less here. Then I asked for the concrete requirements. What is your tenancy model? Like, this gets to the first set of questions here is all about your business. How do you separate your customers? How do you deliver your software to your customer? How many customers do you have? How much does each of your customers use each piece of your system? Those are critical. It's like, you're going to ask for a reference architecture, right? Reference architectures don't take into consideration things like tenancy or software delivery models, right? Like, some software shops will build and deliver software where it's just the engineers and they put it out and it's on the internet and that's it. There's no customizations of any kind. But then, like, especially if you get into enterprise customers where things aren't exactly the same per system and you've got like 30 years of history behind stuff you got to work with, like you're going to start to realize that some of these customers, they have integrators that need to take that core software package, modify the living heck out of that stuff, and then go deliver it and then do more customization and work with them. It's a completely different delivery model. The tenancy model could still be the same. I have a system for you, I have a system for you, I have a system for you, but instead of it being the same exact system deployed by the same exact people, the delivery model gets to who does the deployments, how complicated are the deployments, how much customization is in these deployments. That's a big difference. So you really need to take that into account. You can't just take a reference architecture and do that. Like you really need to take that into account. Other things that I say are, what's your recovery time objective, recovery point objective, and uptime targets? They should have these. They should have these. I find that a lot of customers don't have these, and then they just start making them up. I've had a lot of customers who are just like 5 nines, or I had another one. I'm getting onto a tangent where they had this expectation of like ridiculous recovery time objective, like the cloud recovery time objective must be less than like 2 minutes, and they have like a centralized communication tower, one communication tower servicing like a very large area for all of the things that need to talk to it. And I was like, well, what happens if it gets struck by lightning? Well, what goes down? Well, how long does it take to fix it? I don't know, 48 hours. It's like, so your recovery time objective is not 2 minutes. Your recovery time objective is like 48 hours, because the thing that actually freaking matters is all the stuff that's over there on premise. You're just using the cloud as like an ad hoc compute system. If your communications go down and you have no desire to improve that, it doesn't matter if the cloud has a recovery time objective of 5 minutes. If your recovery time capability for what the value of your system is 48 hours, then your realistic target's supposed to be 48 hours. So you got to look at things like end-to-end as well as subsystems. So like a lot of times they don't even have that number, and a lot of times they'll come in just making stuff up. So you really got to hammer on that one. The other thing I want to make sure that they know, concrete requirements. Still on concrete requirements. What are the regulatory compliances that you have? Like, do you have specific things? Like, are you dealing with DoD? Okay, DoD is a very different kind of game than dealing with like healthcare, which is a very different game from financial, which is a different kind of environment from like manufacturing. Anything that involves life, like life or death stuff, they have all sorts of regulations. Like, you need to make sure that you can't just pick like, if the customer has a regulation in place, reference architectures don't really deal with regulatory requirements. So you got to know what your regulations are for the software that you're building. So like 100%, you got to bring that in. Next thing on the plate, I want them to, well, I don't ask them for a threat model. I start off with, have you conducted a threat model? Because man, most customers haven't conducted a threat model. They don't even know what a threat model even is. So, you know, I'm like, have you conducted a threat model? If so, what are your threat vectors? If not, you should probably conduct a threat model. For folks who aren't familiar with this, there's a MITRE framework, and it covers attack, it covers defense. I like to look at both the ability to attack as well as the ability to defend. And when you understand both sides of the frameworks, you understand the process of attacking as well as the process of defending, and it allows you to come up with a more comprehensive threat model and how to mitigate that vector. So you can't really build a threat model if you don't understand the attack framework, right? And you can't defend against a threat model if you don't understand the defend framework. So you really need to understand both. You can't just go and like know the defend framework and say, well, I guess I'm going to defend against all the stuff. No, you're going to miss stuff. Like, I isolated everything. Well, sometimes people get in because like they solved your administrator's password via social hacking. Know your threat vectors. So ask them for that. That changes things dramatically. If they're like, we have no threat vectors, it runs like in this thing that has like dudes with guns and like they protect everything and there's no way, shape, or form like that they're going to get in here and it runs completely isolated, go to town. Like, don't need to worry about it. Last item on the list. What's your budget? Like, this is where reference architectures really start to fall apart. Reference architectures, most of the time I look at them, and I look at them, I go, that was built by a salesperson with a quota. Like, that was totally built by a salesperson with a quota. That was not built by an engineer. And the reason I know that is that that's very expensive. That thing's very expensive. Oh, you said you need 2 of them to meet a made-up availability number. Like, if you look at a lot of these, they're like, this is a highly available reference architecture for blah, blah, blah. I was like, well, but the recovery time objective, recovery point objective, and uptime availability were reasonable. Maybe the recovery time objective was 48 hours. Maybe the recovery point objective was 24 hours. Maybe the uptime target's only like 95%. Like, if those are the requirements, most of the time you don't need to double up your infrastructure. And in a lot of the world, like, that type of uptime is better than what they do today. So, like, why are you going to go over engineer way beyond business requirements? Like, if business says this is what we need and what we would have to create value, you don't need to double up your costs. So now, having that budget in mind means that, hey, there are areas, once we go through this, we know what kinds of things we might need to cut, what kinds of things we don't cut. So I always like to make sure that they have a budget in mind so that we can kind of weigh the pros and cons of different solutions. So that's about the sum of what I had for today. I wanted to talk about just, designing and architectures, and if you're dealing with customers who need to have a system designed, especially when it gets to a complicated system, machine learning can get complicated. Often it includes other systems with it. It's not the industry and it's not the machine learning problem itself that typically dictates what the architecture of your solution looks like. It's the other stuff that matters. Like, it's not that it's a recommendation system, it's that it's a recommendation system that's being used to recommend products to people, and it needs to have a latency of 10 milliseconds because people have too short of an attention span. And if I don't have that latency met, I'm going to miss 50% of the population that I'm trying to target. And if it goes down, I know that this solution is worth, say, 50 grand an hour. So every hour it goes down is $50,000. We can start doing math around what like availability should be like. Do we depend on that machine learning system running in the cloud, or do we need to put it on premise? Like, I was going with a customer, and it was this is a little industry, but like the impact of a system failure is death, right? Like, if it fails, people die. So you can't just say that like the whole system's going to run like in the cloud. The life or death situation is in remote areas which are known for poor connection quality. And if you're running software in the cloud where it between the thing that causes life or death and you is a poor connection, you should probably think about putting like out of band processing stuff in the cloud, and then putting your like life critical type stuff close to where the life critical kind of stuff needs to go. And instead of putting one of those, you probably need to think about like 3, 4, 5 with redundant power. So th this is where like, hey, the reference architecture where you do all of your like machine learning in the cloud, you make a post call up to the cloud on a Kubernetes cluster, like, dude, one, do you have enough power to do that? Like, your solar panel's going to handle that? I don't know. Is it sunny all the time? Do you have a big battery? These are requirements that matter. Like, just to think that you're going to go and like pick some architecture from the internet to solve like your customer's problem, I just don't see it. Like, and maybe it's just that I get the like 10% that are extra hard. And like, like I said, reference architectures typically solve for 80 to 90% of the population. But I do a lot of stuff like with critical workloads, like not like they're mission critical, they're life or death, there's big money if it fails, like that kind of stuff. So those systems are a lot more important. Like a video game, I don't know. I was in the gaming industry, and half the time I felt like it was garbage. But like, there can be a lot of money at stake there as well. Now that you've got esports coming up, like, they consider it mission critical, and it's a definition by the business. So I would that's why I like to have the business say and the business value of the things driving these types of decisions. So that long story short, I went over the whole thing again. Hopefully that's some good advice for y'all, and we'll see you next Friday.